Tiago Pinto, who will then go into the aspects of how the urban transport is actually using technologies for the day-to-day drive in the urban transport.
Thank you, Norman. Okay. Hi, my name is Tiago Pinto, and I belong to Huawei's Transportation Business Unit. Today's conference is about the future of transport and how the digital transformation affects the transport sector, namely in the rail industry. It refers to the application of new digital technologies to help companies to cope with the challenges brought by the rapid changes in external environments, to enhance competitiveness in the intelligent society, and promote innovation of management models and business models. For the rail industry, the challenges are always about security, efficiency, customer satisfaction, and energy conservation. With the development of ICT technologies, an increasing number of digital solutions are being applied to the rail industry to help customers to cope with the four core challenges. It is true that the typical technological industries like media and communications already have a high level of digitalization, while the more traditional industries, such as rail and metro, are still in the early stage of their digital journey. However, digital transformation based on the application of new ICT technologies is becoming a consensus in the rail industry, and an increasing number of rail and metro companies have already embarked on digital transformation strategies. In Europe, Deutsche Bahn released DB 4.0 in 2015 and started the cloud-based IT service migration. Similarly, Austrian OBB, Switzerland SBB, and Russian railways have proposed their own digital transformation strategies for rail operation and maintenance. In Asia Pacific, the 13th five-year plan for railway informatization construction in China will build an integrated information platform. Hong Kong launched Rail 2.0 to improve operational efficiency and passenger information. Another example on Singapore Metro that has integrated multiple control centers and enabled predictive maintenance based on big data. Digital solutions for the rail industry are evolving from the traditional silo systems and services towards intelligent applications, centralized resources, and diversified connections. In terms of application intelligence, smart rail initiatives and predictive maintenance are being popularized rapidly in the industry. With the development of railway informatization, the integration platform becomes even more important. For example, China Railway has built its main data center to carry the ticketing and dispatching services across the country and gradually migrate and integrate applications scattered in railway bureaus. In terms of diversified connections, with the simultaneous development of rail reconstruction and new construction, the connections along the tracks evolve to large bandwidth and wide coverage, and the unified access and bearing of historical narrowband systems must be considered. The development of rail digital technologies cannot be achieved without the acceleration of the application of underlying new ICT technologies. The maturity of cloud, big data, IoT, AI, and 5G technologies has effectively promoted the progress of rail digitalization. Let me share with you some use cases where these new ICT technologies have been applied. 5G is the new generation of wireless transmission technology, which we have heard several times already in this conference, which is combining high bandwidth, low latency, and massive connections, which enables several innovative solutions to help improving the operation efficiency. The urban rail is an environment where huge amount of data is generated and need to be transferred. For instance, the HDV video recordings from the onboard cameras. Shenzhen Metro uses cameras on board to monitor the rail, the overhead line system, and inside the compartments. All these high-definition images can easily take 25 gigabytes of storage space, which requires long data transfers, which are done typically at the depot at the end of the day. In this use case, Huawei applies 5G technology to transfer all the data automatically as the train arrives at the station in a fast and secure way. We were able to cut a typical train-to-ground data dump from 90 minutes down to just 3 minutes thanks to the ultra-broadband connection. Combining a safe, reliable, and efficient operation together with the pressure of cutting on operation and maintenance costs is quite challenging. So using digital solutions can be a powerful tool. In this case of the smart O&M platform, the data is collected and stored in the big data platform, and then based on AI and algorithms such as health evaluation, life prediction, and fault prediction of trains and tracks, the system can manage the full life cycle of assets, reduce the train running risks, lower the O&M costs, and improve efficiency. Let's take predictive maintenance as an example. A complete predictive maintenance process is a physical closed loop, which includes 4 key steps. First, digital inputs are collected by systems or sensors. Second, the data transmission is supported by multiple communication networks. Third, the data is analyzed and the forecasting is done. And finally, the analysis and prediction results are then used to guide or directly interfere with the maintenance services. This is a common approach also used for many other services, such as passenger flow or energy consumption analysis. Currently, predictive maintenance of railway infrastructure is already being carried out by railways in several countries, such as Germany, Russia, and China. The construction of an urban rail line is where it all begins, and the smart construction is another good example of digital technology usage. Keeping track of the construction progress, ensuring the overall rail construction security and quality is made possible thanks to the usage of big data and AI. The platform dashboard displays the comprehensive project information covering the full life cycle of the track construction, from planning and design to construction, acceptance, and operation. The map allows us to understand the construction progress and security quality, and identifies site security risks to improve inspection efficiency and reduce inspection workload. Using AI capability, it is possible to detect security risks and dangerous behaviors, and so issuing safety dispatches to the railway area. This way, we can reduce the occurrence of accidents. So the smart construction combines construction management with security monitoring at the same time that accumulates asset information for future rail operation. A good example of application of these new ICT technologies is the TOCC, the Transportation Operation and Command Center at Shenzhen. It is a powerful tool that covers more than 50 functions and over 500 metrics that continuously being updated and growing. We will later show a video regarding the TOCC, but I would like to highlight the following topics. First, the comprehensive situation awareness. Accessing the multidimensional urban transport group data through the digital platform, we can obtain the global situation in real time, enabling the display of the operational condition of the entire transportation system. This also covers the safety and security modules, as well as the smart construction that I previously mentioned. Second, the decision-making support. Through big data analysis capabilities of massive cross-department data mining, it processes data in various phases, including metro planning, construction, operation, and development, providing a valuable support for the decision-making process and development planning, including the handling of major events. And third, the Emergency Collaborative Command. It is a 24/7 real-time supervision, which is responsible for incident management and joint command of global-level emergency situations. Without a doubt, that building a coherent transport ecosystem is a key competitive advantage for the city, the region, or even the country. The digital transformation cannot be achieved overnight. We need to continuously develop new skills, new processes, and new products to build new working methods. Digitalization cannot work alone. It requires long-term partners to support and grow together. Digital transformation is driven by vision, global planning and design, such as consulting and planning, top-level design, architecture design, and data governance need to be implemented. On December 2018, Shenzhen Metro and Huawei set up a joint innovation lab to provide systematic assurance. Besides the new ICT technologies such as IoT, big data, AI, and digital platform, Huawei provides consulting services to help Shenzhen Metro to implement the top-level design and the overall framework for digital transformation. Together, we have jointly defined the vision to become an advanced, comprehensive rail transport group that represents world-class standards and provides better services for passengers. In case you have any questions, please address them through the available channel and we'll be happy to answer. Thank you for listening, and now I'll hand over to my colleague, Norman.